Welcome to your first lesson of the Cybersecurity course. The fact that you are here means that you probably already know that when most CEOs are asked what is top of mind for them, cybersecurity or information security is always in the top 10 items. Whether it is a large company or a startup, protecting the information, assets, brand, intellectual property, and their customers is a big concern for all. And it should be, because as fast as cybersecurity solutions have grown, we think it's a good idea to start each lesson with a roadmap of what we will cover in this session. We do this because it helps set expectations, so let's dive right in and start our discussion about networking. So, what exactly is computer networking? Well, it could be described as a pool of connected network devices, such as laptops, desktop servers, etc., that are all communicating with one another and sharing data and resources. There are many terminologies when it comes to networking, but there are a few that people who work in computer networking would use on a daily basis, a kind of computer networking language, if you will. The first word that you're going to get used to hearing a lot is the word packet. Basically, packets are segments of data. A packet generically contains useful information that helps the transmission from source to destination in a network. Ethernet is a standardized technology for connecting devices in a local area network, LAN, or wide area network, WAN, with Ethernet cables. Basically, it aids communication between devices sending resources. Of course, there are many terms that we're assuming you already know. There are the very obvious ones like Internet and World Wide Web that are too obvious to even talk about. And then there are others like LAN and WAN that computer geeks use all the time, assuming people will know what they mean. So just checking you know what we are talking about, and more importantly, what the difference is between the two. A LAN is a local area network that basically covers a small geographic area like a home or office or building, while a WAN is a wide area network that covers a broader area such as a city or region. The domain name system, DNS, is a hierarchical naming system that translates domain names to IP addresses with the help of the fully qualified domain name. Internet Messaging Program, IMP, is a web-based email system that allows the upload of data to an existing web server. IMP was first used when data was transmitted on ARPANET, ARPANET, one of the earliest wide area networks. A firewall is the first line of defense in a network. It helps in monitoring incoming and outgoing network traffic. With set instructions, a firewall could decide to allow or block specific traffic. Protocols are the set of rules or regulations used by connected devices to communicate over the network. It can be said that the protocols are digital languages that are implemented in the form of network algorithms. There are many different protocols, and we cover most of them in the summary notes for this lesson, so be sure to pop along there to read up on all of them. However, due to time limitations, we're just going to hone in on the main ones now. The Transmission Control Protocol, TCP, is one of the protocols that is often used in communication in networking. It is a reliable protocol that uses a three-way handshake to verify connectivity before data is sent. It is used in email, file sharing, and downloading over the internet. User Datagram Protocol, UDP, is a protocol used in networking where a higher speed of transmission is required and data loss tolerance is low. UDP works particularly well in network communications such as voice calls, domain name system, DNS lookup, and video streaming. The Internet Protocol, IP, works as a unique identifier for a network device. The data, or packet is enclosed with the sender IP and the recipient IP addresses to make it easier to locate the recipient address. Internet Control Messages Protocol, ICMP, is one of the most commonly used protocols when it comes to error checking and communication reports between two hosts. It works on an IP basic approach to check the connectivity, utilizing the ping utility to send ICMP echo requests to a host to confirm the status of the request back to the sender. The Hypertext Transfer Protocol, HTTP, is another commonly used protocol. It aids the use of text, images, graphics, multimedia, and the downloading of information, data from a client to a web server. It runs on port 80 and uses hypertext markup languages to serve the request from a client or web browser to a web server. The File Transfer Protocol, FTP, aids the provision for uploading and downloading files and data from a remote host running on an FTP server. It gives users the ability to view, edit, and even delete the file on the server. There are a whole host of other protocols to enable computers to communicate with each other. You'll find more in the summary notes for this lesson, and you'll find the summary notes under the Course Materials tab. Network cables, switches, routers, hubs, repeaters, bridges, extenders, and network interface cards. Network cables are used in connecting devices together. For example, a laptop connected with Ethernet cables to switches. A switch is a network device that is able to send traffic on the same local area. A subnet is a smaller network inside a larger network, such as the internet. A router is used to send traffic from one IP subnet to another. A hub can be used to replace switches as they both have the same capability. The only difference is that a hub has only one collision domain. Let's stop for a quick fun fact. Do you know the difference between a hub and a switch? A hub uses half duplex. Communication in a hub allows the transmission of traffic in both directions, but not simultaneously. A switch uses full duplex. Communication in a switch allows the transmission of traffic in both directions simultaneously. Back to our quick check of hardware items used in networking. A repeater is a network device used to regenerate or replicate a signal. A bridge is a device used to interconnect two LANs operating two different networking protocols. An extender is a network device used to amplify a network connection. And finally, a network interface is a hardware component that allows a computer to connect to a network. So there you have it. How did you fare on your knowledge of the different hardware items used in a networking environment? Let's move on to data transmission across a network. The Open Systems Interconnection Model, or better known as the OSI model, represents the steps of a networking system. It was first made public in 1984 by the International Organization for Standardization, ISO. Its architecture consists of 7 layers that we will look at now. These layers are physical resources, data link, network, transport, session, presentation, and application. Physical resources are things such as cables, hub, repeaters, and network adapters. All these things have the means to transmit bits or information across physical connections. The data link layer comprises 2 sublayers, MAC, Media Access Control, and LLC, Logical Link Control. It provides a means for exchanging data frames. The devices that mainly operate in this layer are switches. The network layer receives frames from the data link and sends them to the intended destination with the help of IP addresses. The devices that mainly operate in this layer are routers. The transport layer houses the error check sequence and manages the delivery of the packet using TCP or UDP. Remember those protocols? The session layer manages conversations between two devices, such as a host and a client. The presentation layer formats or translates data to the application. And the final layer, the application layer, is where the user interacts with the software. For example, a user logging into Facebook. Ever heard of the terms data encapsulation and de-encapsulation using the OSI model? When a packet is created, it goes through different stages of alteration through the OSI model. At each layer, data is either added or removed from the header. Data encapsulation refers to data binding when a packet is created. A logical bit of data is altered to form a PDU, protocol data unit, which comprises of the user's data. An additional TCP segment is added to the PDU, protocol data unit, followed by an IP packet segment, and lastly, an Ethernet frame to form a complete packet that is sent from web server to web client. Data de-encapsulation is the reverse of the encapsulation process, where the PDU, protocol data unit, is removed one after the other to get the raw data. Now that we have unpacked the OSI model, let's take a look at some of the benefits of using it. The OSI model assists in protocol design. Since protocol at each layer has a defined purpose, it makes it easier to build more protocols with the defined logic of the model. The OSI model also encourages competition. The concept of the OSI is defined as an industry standard with which any vendor manufacturing network devices will have to comply. The structure of the model separates interfaces and protocols, which gives it adaptability. The TCP IP model is a contracted version of the OSI model. The stack is a set of communication protocols used by the Internet. It was created in the early 1970s for internetwork communication. It consists of 4 layers: the network access layer, the internet layer, the transport layer, and the application layer. The network access layer is the aggregate of the data link layer and physical layer available in the OSI model. It controls the hardware devices and media that makes up the network. The internet layer is like the network layer in the OSI model. It is used to send data, packets, from the network to a destination. This layer determines the best path through the network. The transport layer supports the communication from the source to the destination host without defects. And the application layer performs the representation of data to the users, which gives the user dialogue control. So, as already mentioned, and is clear from this comparison, the TCP/IP model is basically a summarized version of the OSI model. We're now going to move into the final section of this lesson. We'll look at the different network topologies. Network topology is the way a network is arranged. Network topology plays a vital role when it comes to structuring your network. Network topology can be physical or logical. Physical network topology reflects more on tangible connections, such as wires, cables, and devices. It shows how the network is structured. The logical network topology is more the conceptual and strategic structure of the network. It shows how data information will be transmitted. Creating a network topology is a vital aspect of setting up a business. Being able to plan and set up a flexible, secure, and maintainable topology is a big plus. As you can see here, there are quite a few common types of network topology, which all suit different business models, and we're going to look at each of these now. Keep an eye out for an email from us after this lesson, because the common topologies are so handy to use as a starting point when planning or reviewing a network. We've made a nifty little table of them for you to save and refer to when you need to. Network topology is an extremely important fundamental in cybersecurity. Why? Because it is essentially an overview of your computer network. If you know the topology of your network, you can make better choices about the hardware and software to use in your company. We have compiled a summary of the different topologies we're about to discuss in a table for easy reference, which will be sent to you after this lesson. It will go into a bit more detail on the pros and cons of each option, so be sure to store it somewhere safe, as you will definitely need it down the line. Star topology is one of the most common network topologies. It has a visual representation where every node is directly connected to a centralized hub or switch with cabling, such as coaxial, twisted, or a fiber optic cable. The centralized node manages the transmission of data across the topology. The star topology is very easily managed because of its structure. The entire network could be managed from the location of the node. The structure of the topology makes it very easy for expansion of the network. If more devices are needed to be added to the network, they could be connected to the centralized node. One of the major problems with star topology is when the central hub goes down, the entire network goes offline. A bus topology has a visual representation where devices connected are connected along a single cable, running from one to the other on the network. A common way of describing the bus topology is a line topology, where data is transmitted from one to another on a line. The bus topology structure makes it very cost-effective in design implementation. The topology makes it easy for growth expansion. If more devices are needed to be added, they're simply connected to the line connected to the node. On the downside, bus topology is very vulnerable in the sense if the cable connected to the node is faulty, all devices will lose their connection. Bus topology is also mostly suitable for smaller networks. In the case of the ring topology, the node is all arranged in a circle format, where nodes are neighbors with each other, giving the flow of data in a circular direction. The ring topology greatly reduces the risk of collision on the network, since only one node can transmit data at a time. The ring topology has a good structure of flow of data. For example, the data flow in a circular path until it gets to its destination. The ring topology is cost-effective and cheap to install and manage. On the other hand, the ring topology is very vulnerable to network failure due to the network structure. If one of the nodes goes offline, the entire network loses connectivity. The topology requires a lot of monitoring to be able to detect network failure. Dual ring topology is a very similar topology to the ring topology, but in this case, data only travels in one direction at a time. The dual ring is known as half duplex because of its nature. One of the main advantages of the dual ring topology is redundancy. If the topology is structured to be more efficient, traffic mainly travels in both directions in the network. The main drawback of this topology is the cost. Being able to implement the logical and physical nature of this topology will cost a lot of funds and resources. The tree topology gets its naming from the visual representation of the network, where the centralized node is directly connected to a secondary node, and devices in the network are connected to the secondary node. In this case, there is a form of trunking from the centralized node, secondary node. The best benefit of implementing a tree topology is management efficiency. Due to the structure of this topology, it makes it easy for troubleshooting issues on the network. Growth expansion of the network is very easy to implement. If another device is needed to be added to the network, it is very easy to tag the device to a branch of the network. The major drawback with this topology is that if the centralized node goes offline, the entire branch loses its connectivity. The entire network solely depends on the centralized node to function. The tree topology is not cheap to implement, considering the cost of cabling required to connect from the centralized node to the bottom of the hierarchy. The mesh topology has a complex structure that gives it a lot of redundancy in the network, where there is a point-to-point connection from every device in the network to the centralized node. This type of topology is very common in large networks where companies need a lot of redundancy in case of a network failure. If a link goes down from the device to the centralized node, traffic can still be transmitted from the other link available. The mesh topology is more stable and reliable due to its structure. So, in case of a network failure on the link, there is another link to the traffic to fall back on. One of the drawbacks of implementing this topology is the issue of cost. Setting up a mesh topology is not very cost effective. The other is the complexity of the topology. Setting up a mesh topology is very complex to set, where you have link cables interconnecting all devices in the network. The hybrid topology is an evolved form of a network topology, where it combines two or more types of network topology. This type of topology is mostly found in a large organization where companies structure the topology to suit the different departments of the company. A typical case would be combining the mesh topology for the networking department, giving them a lot of redundancy, and structuring the bus topology for the marketing departments because they need to be on the same network and share resources among themselves on the network. The main benefit of implementing this topology is flexibility, where more than one of the types of topology can be added to create the structure a company or organization wants. The drawback of using this topology is the complexity. The more different types of topology is added to the network, the harder it becomes to manage. It's also not cost efficient. Being able to implement a hybrid topology will cost the organization a lot of funds and resources. So, from what we've just discussed, can you identify some of the key factors that you would need to consider when choosing a topology for your business? A clue. There are 4 main ones we have identified. Cost. That's an obvious one. Time. The time duration to fully create a logical and physical representation of the topology. Management. How easy it will be for the network administrator to be able to manage the system in the case of detecting network failures. And redundancy. Companies will have to select the types of topology that has multiple resources that serve the same function and can replace each other in the event of failure.